Hey, Matt Mathersum here with Math Madness. On this show, we use a little bit of madness and a little bit of mayhem to teach you some fundamental math principles. It's all about making math fun. All right, so before we begin, let's address last week's brain twizzler. Okay. Well, if you remember, we asked, what do these numbers represent? 66952. Now, this is a little tricky. Well, this actually is the zip code for the center of the United States, which is located in Lebanon, Kansas. Don't ask me why I'm on this Kansas kick, but I have been for several weeks. I may or may not eventually get off of it. All right. So before we begin with today's episode, let's examine a little bit of what we discussed the last time. We addressed prime cost, which are two expenses, right? It's food cost and it's labor cost. We analyzed how to calculate for both. We know that prime cost in the restaurant business is around 60%. We know how to calculate this as well. We know what cost to sales ratio means, and we know that these KPIs, which mean key performance indicators, right? So let's continue on with Big Daddy's Burgers and how it's going to achieve profitability. The first thing we really need to understand is our food cost, and then adding our desired profit margin. In our case, our Big Daddy's Burgers, well, let's just use this scenario as a base for our burgers, okay? Here, and let me flip this board over because I've already got some of these numbers written out for us. Here's our burger cost, okay? Our bun is 45 cents. Our tomato is 56 cents. Our lettuce is 50 cents. And our cheese is $1.88. Cheese is always usually one of your more expensive ingredients, almost in no matter what restaurant you're in. This gives us a whopping total of $3.39 for our total cost. All right. So is this all we need to calculate our selling price? Well, not quite, my precious. Some other things to consider in the menu pricing are perceived customer value, competitor prices, menu mix. Okay, now that we know a little bit more about menu pricing, let's let the mathing begin. Now you can see over here, I've got SP equals FC divided by FC percent. Well, what kind of crazy mathematics is this? Well, this just equals selling price. This is our food cost, and this is our food cost percentage, okay? So we'll come back to this in just a second. Let's say it cost us $3.39, which we agreed on down here, that it costs to make our Big Daddy's Burger. So plugging in our numbers to our formula, it gives us this equation. We're solving for selling price, right? We know what it cost us to make our burgers, but we want to know what our selling price is. So how do we calculate this if we want to add, say, a 30% food cost? Well, let's start again with our $3.39. And that would be our food cost, wouldn't it? $3. Well, it's going to fight me here for a second, but we'll get it. So $3.39. And we said that we want to have in what? A 30% food cost. So we're going to divide that by, right, 0.30. Then what is that going to give us? Get your calculators out to give me the selling price, which is a whopping, $11.90. All right. Sorry, $11.30. I had a momentary lapse of reason. $11.30. All right. So looking at this number, what are some adjustments that we could potentially make to become more profitable? Well, how about if we engage in some rounding activities? Looking at our primary competitors, which you could always and should always be doing, we could round up to $12, right? We could take that $11.30 and round it up to 12. Or if times are a little bit tight, we could round it down to 11. Experiment with your numbers so that you can maximize your assets without turning off your customers, really is the name of this game, okay? Now keep in mind that we didn't include labor cost, rent, or other expenses associated with making this burger. In general, once these costs are added in, profit margins are typically between 3 to 5%. So think about it like this. If you made $1 million in sales and your profit margin is 5%, you made $50,000 on $1 million.
Multiplying mayhem, multiplying mayhem, multiplying mayhem with Mayhem Matt. Yeah.
Well, thank
and
you,
here's our host
Mimi,
of Multiplying
for that effulgent
Mayhem,
introduction.
Mayhem
it's much
Matt.
appreciated. Welcome to another exciting round of Multiplying Mayhem. I'm your host, Mayhem Matt. Let's get started. Well, today's topic is going to be on finding the lowest common denominator, plus we're going to include some fractions with multipliers in them and multipliers with fractions in them and any other kind of concoction you could possibly create. Well, you know where I'm headed with this. So let's get ready to rumble. In the upper right-hand corner, middle, and left-hand corner, we've got this. If this doesn't terrify you, and should it? Yes, it absolutely should terrify you. I'd rather deal with the principles of conservation of mechanical energy than to have to deal with this mess. But if you're still here with us, upon closer inspection, is there a way that we could probably knock this out relatively quickly? Maybe. Let's take a look real quick here. So remember we talked about finding the lowest common denominator in our introduction? We've got 4, 2, and 8, don't we? Yes, we do. Well, could we find the lowest common denominator out of all of that in order to multiply this whole thing, to eliminate it, obliterate it, and bring it all the way down? I think we can. So let's see what we've got here. Well, we've got an 8, we've got a 2, and a 4. What's the lowest common denominator out of those three? Well, you know that, and I know it. How about 8? 2 goes into 8 4 times, 4 goes into 8 2 times, and 8 goes into itself. Well, you know how many times it goes into itself. So, that being said, let's multiply this whole thing by 8 to get rid of these fractions and to just lay waste to the rest of it. What do you say? Here we go. All right, now you can see what it looks like after I've multiplied everything by 8. I haven't solved for anything yet. This is just the setup to make that happen. So take a look at this real quick before we just annihilate this. And we're just going to start from the left to the right, aren't we? Yes, we are. So let's come over here. We've got the 4 in the denominator, don't we? And we said we're going to do this to eliminate the fractions because we hate working with fractions. 4 goes into itself how many times? 1. How many times does 4 go into 8? Dos, that's right, 2 times. What are we left with now? Well, we can see we've got a 3, and we know distribution is in our future, but it's not just the 3 to the x or to the negative 2. We've got to multiply 2 times 3 to get 6 first. Then 6 times x gives us, that's right, it gives us 6x, doesn't it? All righty, let's get the 6x here. Now, we've got 2 times 3 again, which gives us 6, but we've got 6 to the negative 2. That's going to give us, that's right, negative 12. All right, you see what we've done? We've just got rid of this fraction in this problem really quick. Let's move on over here to this mess. We've got 2 on the denominator, and we've got 8 up here in the numerator on this side. Well, let's just go ahead and get rid of the 2 here. 2 goes into itself 1 time. Yeah, 2 goes into 8 4 times. Excellent, you guys know this so well. What are we doing now? Well, we're going to take the 4 and multiply that by 1, but then that's still going to give us 4, but we've got to distribute that to the 5x, don't we? That gives us, right, 4 times 5 is 20x. Excellent. Now, again, we've got to say 4 times 1 gives us 4. 4 times 2 is going to give us a positive 8, since that 2 is positive, right? Look, we just got rid of that mess. It's going relatively simple, isn't it? This is all equal to what we're getting ready to solve over here. Look what we have here. This is going to be easy peasy. We've got an 8 here. It goes into itself 1 time, doesn't it? It goes into 8 1 time again. Well, what are we left with now? Well, we got 14x plus 12. Can we combine like terms? No, these are not combined like terms at all. Don't get tripped up on this. The 14's got an x. What does that x mean? We don't know, but it's a number of some sort, but it is not like the 12. Keep that in mind. So let's just bring that down over here. We've got 14x here. Going to add that to 12. But no more fractions, right? Well, what are we left with here? We've got 7 being multiplied by 8. Let's just go ahead and get that taken care of. That's going to give us what? 56? All right. We've gone from this to this. It looks a little rough, right? But we're going to knock it out here. This is going to just take care of the majority of it right now. Let's go ahead and combine like terms. I knew you were going to say that. On the left-hand side, sounds good to me. We've got a 20x here. We've got a 6x over here. Yes? Let's do that. So that's going to give us what? 26x. I love it. 20x and 6x are gone. Well, what are we left with now? A negative 12 and a positive 8? What is that going to give us? Fingers and toes, negative 4, is it not? It absolutely is. Taking care of the left-hand side, look, now it's this. Okay, let's deal with the right-hand side. I'm going to bring this 14x over here. And then I'm going to add, let's just go ahead and knock out the 12 and the 56. 12 plus 56 gives us what? That's right, it gives us 68 indeed. All righty. Well, what are we left with now? Well, you know where I'm headed with this. I know you're eyeballing that 14x. I'm eyeballing it. Let's get it out of here. Move it to the left-hand side. Sounds good to me. We are solving for x. We agreed upon that, yes? Okay, perfect. Then let's get the 14 out of here. But what is 26? X minus 14x. That's right, it's going to give us a negative 12x. Let's bring down our negative 4 here. Bring down our equal sign. We've only got 68 on the right-hand side, don't we? You see how this is shaping up? We're not far from the finish line, no? What is the impediment keeping us from isolating that x? You got it. It is that pesky negative 4. Can we get it out of there? Let's get it out of there. If I want to do that, what am I thinking? Inverse operations? Great idea. Let's add the 4 to the 68. What does that give us? It gives us 72, doesn't it? It most certainly does. But what are we left with now? Well, I've got a negative 12x on the left-hand side. I've got a positive 72 on the right-hand side. I'm solving for x. I want to get x by itself. Why? So that we can be done with this. What do I do if the x is being multiplied by a negative 12? That's right, inverse operations to the rescue again. Divide both sides by a negative 12. That's going to isolate the x, giving us just x over here on the left-hand side. It certainly is. But if I do it on the left-hand side, what do I got to do? I got to keep everything in balance. And I realize I'm the last person to talk about balance, but that notwithstanding, I got to divide the 72 by the negative 12, giving us a, wait for it, that's right, a negative 6. Negative 6 times a negative 12 gives us a positive 72. Ergo, x equals negative 6. Is negative 6 our answer? And most definitely is our answer. Thank you so much for being here today. We're out of time. Join us next time for another exciting episode of Multiplying Mayhem. I'm your host, Mayhem Matt. Good day. Welcome back to Math Madness. So let's do a quick review. We know that in order to price our menu correctly, we have to look at our operating environment in order to see how to price our menu accordingly. We know that we have to calculate our selling price, which is predicated on our food cost percentage. We just take our food cost and divide that by our food cost percentage, and this gives us our selling price. We know that margins are extremely thin, anywhere between 3 to 5%. You can roughly expect that. Okay, well, this concludes today's episode. So for the moment you've all been waiting for, this week's Brain Twizzler. Okay, well, thank you for that. Which number is spelled with the letters? Which number is spelled with the letters in descending order? Which number is spelled with letters in descending order? Well, thank you so much for joining us today. As always, keep on counting and keep on creating. I'm Matt Mathersum. We'll see you next Monday.